In my last video, I made these little titanium heat exchangers using the super glue and tape method. But at the beginning of the video, I was struggling with the process. And at the end of the video, it was working fine. And I just kind of glossed over the lessons that I learned. That video was about 3 weeks ago at this point. And in the last 3 weeks, I've made about 6 different parts using the super glue method. And I have learned a ton. In this video, I am gonna be making some parts out of this big sheet of brass. But more than it being a project video, it is going to be an instructional video teaching you guys all of the lessons I have learned about using super glue for work holding. So when do you use super glue work holding? Well, the easy answer is thin and delicate parts. For example, this part here, this was a perfect use of super glue work holding, because if you tried to hold it with any sort of physical clamping, it would deform the part, which would ruin my flatness tolerances. Another good use case for it is large parts, particularly ones where you want to access all sides of it, or if you're working with expensive materials and you want to sacrifice as little as possible to work holding. For example, if you are a knife maker working out of like Damascus steel, you don't want to hold the bottom of the steel in a vise here and lose like 1/8 of an inch off the bottom. You want to be able to use the whole thickness of that material. In super glue work holding, since it's zero profile, you can use the entire thickness. There's also quite a few applications where super glue work holding doesn't work very well. For example, if you have a high aspect ratio part, if you have something that's tall, this will have a lot of leverage on your super glue. Another thing is if you're trying to work fast. Switching out a part in a vise, if you're slow, takes like 15 seconds. But doing all the prep work for super glue can easily take half an hour. So if you're doing low dollar value, high production work, you do not want to touch super glue. Another place where super glue work holding does poorly is for locating your part. It does really well on the work holding side. You can cut rather aggressively if you have enough surface area with super glue, but it's really hard to locate and index your part. So most of the time, if you're doing super glue work holding, you want to start from an entire sheet and do like your op1 work in the super glue work holding. You don't want to try to, machine something that's already finished, because locating the part on your machine is going to be difficult. If it's something flat like this, you can't get a probe in there to probe the side. There's no way to index it. Soft jaws in a vise work better for that kind of application. So let's start this project with stock prep. This material happens to be rather nice and comes with this plastic on here, but this nice shiny surface is actually more of a liability than it is a benefit. So to start with, we need to take this material and we need to saw cut it down to 6-inch squares. Now, basically any metal supplier will sell you smaller pre-cut pieces of material, but watch out, a lot of them shear the material, and not only does it leave a big burr on one side of it, that shearing in some materials can also add a lot of internal stresses. I had big issues with that in titanium in the past, where because it was a relatively small piece that was being sheared on 2 sides, that material wanted to twist, and it would literally bend up at 90 degrees on me. So if you can, have your material supplier saw cut the material for you, or start with a bigger sheet and saw cut it yourself if you have that ability. But now we get to start the slightly tedious process of making sure that this sits flat on your fixture. Now, depending on the kind of work you're doing, the amount of precision you're going for, the amount of material removal you're inflicting on your stock, some of this stuff can be abbreviated a little bit. This first step cannot, and that is making sure there are no major burrs around the edge of the material that will keep it from sitting flat when you glue it on. The easiest way I have found to do that is to go around the edge either with a belt sander, or I really like the Scotch-Brite wheel on this buffer here. So this is where you can maybe take a little bit of a shortcut. So if you are not aiming for super flatness tolerances, you can just take Scotch-Brite and just kind of buff this off, get the whole face of it looking smooth and shiny-ish. This will not add any flatness to it, it'll just help with the glue adhesion. Now, if you do care about flatness or just want a generally more reliable process, I would recommend flattening one of the sides of your material. I'm gonna do that on my glass plate here that I use for sanding. If you don't have a 1/2-inch piece of bulletproof glass like I happen to have for some reason, you can always use a cheap surface plate off of like Facebook Marketplace, or there's like the Grizzly one off of Amazon. It's like 70 bucks. It works really well for this. You can also just use regular sandpaper, glued down or not glued down. If you have regular sandpaper and you like to glue it down, you can use something like Super 77 or even like a rubber cement to keep it on your glass. I happen to just have these strips of sandpaper that are adhesive backed. I honestly don't like them as much because they're too difficult to get off the glass. But once they're down, you can just put your material on here and start trying to do some circles. Now, you may notice I'm kind of struggling to hold it here and I'm sanding my fingertips. There's an easy way around that. I like to get a little bit of duct tape and make myself just a small handle like that that I can hold on to as I smooth this down. Though be careful, especially if you're working with very thin stock, how you have the handle positioned can change where you put force on the material. So if you're aiming for like really flat flatnesses, it can distort the material and change where it's being lapped down, which will change your flatness. You'll end up with high or low spots depending on where you want to put pressure on. For this part, it doesn't matter, but even still, I'm just going to kind of do some circles, rotate it, do some circles, so on. You can do it 90 degrees or whatever you want. And that piece of tape is just a nice little handle to make sure you don't sand your fingers. Now, I'm not qualified. I don't know enough about lapping to talk to you about getting to like really, really dead flat parts. If you want to learn more about that, go to like Ox Tool or Robin Renzetti. They're much more knowledgeable about this and have better resources than I'll ever have. Now, if you're not going to go through all that effort, and that's fine, you don't always need to, but at a minimum, I would say take a stone and do a light stoning across your piece of material just to check for any high spots, and then Scotch-Brite, and then you can move on. And it doesn't need to be a precision ground flat stone, just anything will do. So stock prep is done other than final cleaning. On this one, I am not machining the top or the bottom. I am just profiling and doing some chamfers. So I went ahead and did that same sanding on both sides of them, lapped it down smooth and flat, and these will get tumbled afterwards. But that just kind of gives it a nice, flat, consistent, scratch-free finish that will leave a nice looking tumbled finish. With our part completely prepped, now we get to move on to the fixturing part. Now, there's really not a fixture per se in this, or at least not something custom. All you need to do is take a piece of material and throw it in a vise. This material can of course be anything, something that'll fit neatly in a vise, or a big piece that you can like clamp down to your table, or like traditional pallet. Be careful with pallets though. I made this one a year or two ago, and I hate everything about it. It's actually worse in almost every way than just putting a piece of material in a vise. When you just stick a piece of material in a vise like this one, you can face it off, and that's what I'm about to do here as the next step. This one, because I put so much effort into it, I put threaded holes and some grooves and all that kind of stuff, you can't just face it off anymore. Plus, the pallet is actually too big to be faced off with the travels of my machine. It's also just heavier and more of a pain, and you have to store it, and I generally don't like it. Going back to the parts we're making, we have a piece of aluminum in my mod vise here. We now just need to face that off. That not only gives us like a clean flat surface, we also know that that surface is parallel with the axis of the machine since it was faced right before we ran the part. To generate the code for this facing operation, I just duplicated my setup here and then removed all the tool paths and added a facing tool path where the bottom height is set to the stock bottom and there is a slight bit of stock offset so it faces an area bigger than the pallet. For both operations, the work coordinate system is in the same place, which is in the bottom center of your part. By doing it this way, you don't have to reset that Z work coordinate offset if you don't have something like a Renishaw probe. We do, however, need to find the center of this piece of material, which I'm gonna do with a straight edge and a Sharpie. There's no need for this to be super, super precise. All right, so there's our center. Now you can just line up either a tool or your probe visually with that mark and set your work coordinate system offset to that point. I have the Rent-A-Shop probe, so I'm gonna use the Rent-A-Shop probe, but there's no reason you couldn't spin a tool in here at like 1,000 RPM and just slowly jog it down until you start seeing chips. Because even with the probe, the next thing I'm gonna do is I'm gonna come over here and I'm going to offset my work coordinate system by 10 thou farther down. All we care about is that the face of the material just gets completely cleaned up. Z servo air too large, excuse me? Oh no, it hit my tool setter. Not anything vital, but that's not good. Good thing this is only an office mill, gosh. I'm just gonna switch to a longer tool. I know that's not the right way to fix that, but that's the easiest way to fix that. With a nice shiny fixture, we can now move on to the next step, which is cleaning and then gluing. There's a couple different ways to clean. I showed acetone a second ago, and I think that is the best method. I just don't like acetone if I can avoid it. It's smelly. You can also use isopropyl alcohol like that with a rag. The easiest way I have found is these little pre-packaged isopropyl wipes. You get like 500 of these things for $6 or just something ridiculous, and they just make it so much less hassle to clean. You don't have to worry about getting paper towels or making your machine stinky or acetone running off onto your table and damaging something. You just pop them out of the package and wipe off your work area. They also have the benefit of being at least relatively lint-free. I don't know if they count as a lint-free cleaning cloth, but they certainly are good enough. So I'm just going to clean off both my fixture and my stock. And from here on out, don't touch the glue face of your part or the fixture with your fingers. But now we get to talk about tape and glue choice. So with Superglue, you have a few options. If you're using the traditional regular Superglue, you get to choose between thin, medium, and thick, and then like the gel style. I haven't noticed a huge difference between those in terms of work holding, but I think the thick, not the gel, but the thick seems to be the easiest to work with. The thin stuff dries too fast and it's too runny. The thick kind of stays where you want it and it dries just a little bit slower, but not too slow. The gel stuff, which is actually what this is, can be kind of gloopy and you can end up with like blobs where you don't want blobs. If you are using this kind of super glue, then you need to use some sort of tape. Painter's tape works just fine if you are not running coolant and not pushing it that hard. But if you are running coolant or you do need to push it a little bit harder, then you need to step up to powder coating tape. I'll have links for all this stuff down in my description if you want to see what I use. The powder coating tape has this lovely advantage of being coolant proof and it can hold higher heats than this stuff. Now, if you're just doing something quick on like a CNC router, this stuff is cheaper and easier and just generally a little bit more forgiving than the powder coat tape. If you're doing like some real machining and you want to use coolant, the powder coat tape is the way to go. It holds better and both against your material and your fixture, but also the glue bond between the two layers is better. But you also have the option of using no tape. The problem is if you use regular super glue, the no tape method doesn't work very well. What you want is this stuff. This is Loctite 480. It is a toughened super glue and it works so much better for tape or not. It works so much better than the traditional stuff. This stuff right here was the biggest thing that I was missing. This is world changing if you're using the super glue method. It's expensive. It's like $20 for this little container, but it is worth it. You only have to scrap one part to make up the price difference. And depending on your part, it could be a lot more. So get this stuff, the black Loctite 480. It also gets called Loctite Prism. If you're using this stuff, you don't have to use tape. You still can, but you don't have to use the tape. You can go straight metal to metal. Going bareback, it gets you the best work holding It gets you the best bond between the pieces. It also gets you the best flatness. The downside is sometimes it's a bear to release your parts, which can be a big killer on teeny tiny parts that are fragile and easily like bent when you go to remove them. So if you're worried about work holding or accuracy, use this stuff with no tape. If you're worried about getting your part released, use the regular glue and this tape. I should add, this tape does have thickness. I believe this stuff is 4 thou thick. So if you have 2 layers plus a layer of glue, that can give you like 10 thou. And you do need to consider that when you're setting your work coordinate system, unless you're just going all the way through your part. We'll run this set of parts twice, first with this stuff and no tape, and then with this stuff and tape. Another thing is activator. This can like dramatically decrease your amount of cure time. It basically makes the glue set up instantly. The downside is it also makes the glue set up instantly. It's definitely worth it if you're trying to work fast and doing something that's low precision. But if you really, really want that part to 100% be glued down, I would skip it. If you use this stuff, it doesn't even give the glue long enough to flow and cover your whole part when you're first gluing it down. Where the glue touches is where the glue will be. And you can end up with like little lumps underneath your part. So it is definitely faster. And if you're like a woodworker doing something on a CNC router, I would absolutely use it. But if you're doing high precision or high dollar value stuff on like a mill, I would skip it and just wait that cure time. Time to spread the glue. Now, I have been told that using too much glue can hurt the bond, and I'm sure that's true. I don't really know where that limit is yet. But what I do is I just kind of go in an adaptive toolpath here and cover the whole surface, spaced, I don't know, about 1 centimeter apart. And then once I'm done with my little toolpath there, I kind of go in a grid. The key thing is you want to make sure you get glue like all the way up to the edges, because the Superglue method fails. It starts to fail at the edges. And then always clean your nozzle before you put the lid back on. And then it's just a matter of getting your part on your fixture. Give it a little bit of a shuffle. I have this big chunk of steel that I use to provide some clamping force, but when the piece of steel isn't big enough to cover the whole face of the part, I put down something bigger that will spread the load, like this piece of aluminum, or sometimes this big chunk of HDPE. The HDPE has the advantage of Superglue not really sticking to it. So if you over splooge, you can easily get this off again. Now that I think about it, it might be worth buying a big sheet of HDPE that I can use solely for this purpose. Once you get the weight on it, I would set a timer from between 15 minutes to half an hour. I've definitely done 15 minutes before and it's been fine. But again, if you're working on something high dollar value, I would wait the full half an hour for it to cure. And while we're waiting for glue to dry, just a quick little pro tip. I like to keep all of my Superglue stuff ready to go here in a bin so that it's all in one place when you need to fixture something. Which is actually another reason why I like the little alcohol pads, because I don't have to try to fit a bottle of acetone in my process bin. The program just finished and the parts are looking pretty good. You can see there was no issues with anything moving or coming loose, though I did leave a 5 thou onion skin on the bottom of them. The backside is going to have a big chamfer just like on the top here, and that chamfer will take care of the onion skin on the back. So this leads to the biggest question I get with the Superglue work holding, and that's how do you release the parts? Particularly, how do you release small parts without bending them? There are two good options that kind of depend on your setup and your situation, which one you should go for. So the first option is a heat gun. The heat gun is nice because you can do it while it is still on the machine. You don't have to remove your fixture so you don't lose any work coordinate systems or anything. It's definitely slower, it takes a long time, And there is the possibility, if you do have some really delicate little parts, that uneven heating might cause some warping in them. It's also slow. Did I mention that it was slow? The easiest method is acetone. And you'll need to use acetone to clean off the super glue at any point, so it's not really adding a step. And that's what I'm gonna do for these parts. I bought this dedicated glass tray from Goodwill, and this is what I use to soak my parts to get the super glue and stuff off of them. So I can just release this whole fixture from my mod vise, stick it in here, and dump acetone on it. So it took a little time, maybe half an hour, but eventually it became loose enough that I could put a little bit of a pry bar underneath there and get a corner lifted. Then I put it back into the acetone. And once you can get the first corner lifted, things go a lot quicker. Acetone has access to all of the glue. And like basically you just pry it up a little bit, you put it back in the acetone, you pry it up a little bit more, you put it back in the acetone. And once you get that process started, it takes like 3 minutes to get the part the rest of the way. Then I put it back in the acetone to soak off the black glue, and now it's looking nice and pretty and good to move on to the next operations. While that was soaking, I prettied up the next sheet of brass, and this time let's use the tape method. So like I said earlier, doing the method with the tape means you can get away with a little bit less carefulness with how you do the surface prep. You don't need to like lap it all smooth. Just take some, like a red Scotch-Brite at a minimum and get your surface nice and clean. And again, the more surface prep you're gonna do, the better. But at a minimum, Scotch-Brite it, and then use either acetone or like an alcohol prep pad to clean it off. This is the side I want to be the bottom. Okay, and just give it a good cleaning with the acetone pad. And now I can start putting tape on the part. When I first put it down, I give myself a fairly wide margin on the edges. And I make sure the part of the tape that I touch with my finger doesn't go onto the part. I'm overlapping them, or excuse me, I am not overlapping them. I'm putting them as close together as I can without overlapping them. It's okay if there's a small gap. It's better than an overlap. All right, trim that off. And now basically this is glued or taped down to the table. That's not the goal, but it is handy because it doesn't move around. And from here, I take my Scotch-Brite again and carefully going with the grain so you don't like knock up an edge, and you want to be careful around these edges. I'm going to scuff up the surface of this tape until it is not shiny. And while doing this, I'm also going to push down any air bubbles. Any air bubbles can hurt flatness, and we don't want those. Now, if you see here, I don't know if it's going to show up, but you'll just have to believe me that the Scotch-Briting actually exposes a lot of the air bubbles for you. They're harder to see before you Scotch-Brite. Plus, like I said, you are actually pushing down the material when you do this. Just get it as good as you can, get as many of the air bubbles out. If there is an air bubble that you can't get out, take a knife like an X-Acto knife or a razor and give it some kind of slashes through it. And that pops the air bubble and kind of gives the material some freedom to move. Then you can come back with your Scotch-Brite and you can kind of burnish down all of those air bubbles. It may take a second and a couple of different attempts to make sure you got all of them, but this works really well for knocking those things out. Now I can see there's a little chip or something here, a little bit of contamination. I'm just gonna cut that sucker right out because I don't want anything messing with my flatness tolerance, and a little bit of super glue on the part isn't gonna hurt anything. Okay, so with all of those bubbles gone, then I can just take my knife and trim right along the edge, getting rid of any excess tape. The last thing you want to do before applying glue is to take another one of our alcohol pads and clean off the tape. Now this one I do not do with acetone ever. I only ever use alcohol on this because I don't want it to interfere with the glue bond on the tape. But again, these alcohol pads are super convenient. After the tape, everything else is exactly the same process. Put the glue on in the same way, weigh it down the same way, wait the same amount of time. It's all the same. You may have noticed the last time I ran this program, I did it with dry air. There wasn't a mist coolant, there wasn't flood coolant. A lot of people think that you can't use the superglue method, especially with tape, with flood coolant. That is wrong. If you are using painter's tape like this, yes, do not use flood coolant. But if you are using the powder coating tape, there is nothing wrong at all with using flood coolant. So last time I used the dry air mostly for filming reasons, but also because I just installed it and I wanted to play with my cool new shiny toy. This time we are going to use coolant because I want to prove to you that it is perfectly fine and you shouldn't be scared of coolant if you use the tape method with the proper setup and the proper tape. Mesh and brass, no time to waste it. Grab the super glue, secure it tight. This here work holding, gonna make it right. Hold on tight, don't let it slide. With every cut, we're taking it in stride. Sparks to fly, as the tools go round in this workshop. We won't be bound. The coolant ended up being no problem at all. All of them were machined, and actually because I originally set my work coordinate system on the metal plate instead of on top of the tape, there is no onion skin on these. It's really hard to see. I don't think you can visually see a difference, but technically that means the chamfers are a little bit deeper as well. That'll be completely unnoticeable once they are tumbled. So now with the tape, a lot of the times it's kind of easier to separate. I say before struggling. I should start by saying this is what I use to do a lot of my part removal with the superglue method. It's a little dirty right now from the last time I used it. Before I use it, every time I bring it to my Scotch-Brite wheel and I just get everything cleaned off so there's no burrs. A little bit of superglue gunk doesn't matter, but anything sharp on here can damage your part, so I just make sure it's all super smooth and polished. We should be able to get this to come right up. And even with as little surface area as there is left on these things, to safely release them without bending, because these are rather delicate at this point, I'm going to use the hot air gun, which will just make it really easy to peel them off. The bigger your part and the bigger your fixture, the longer this takes. But with a small part and a small fixture, it just takes a minute of patience. The hot air gun method works if you're using tape or no tape. It does work better if you have the tape because the tape is easier to release. And of course, the advantage of having tape, besides it being easier to release, is it doesn't leave residue from the super glue on your part. So it just saves you a cleaning step. So now I have a cup full of Op 1 parts. They still need the second op done, which I'm just gonna do in soft jaws. You guys have seen that stuff a million times on this channel before. And this video is not about making these parts, it's about the super glue method. I pretty much can't take credit for any of the information I have shared today. There's been so much generosity in the machining community that I can't even begin to name everybody. So if you have some experience, if you have some knowledge, if you have some skill, don't be afraid to share them, guys. It helps the whole community. Showing off one little trick on Instagram really can make a difference in somebody's life. Anyway, that got philosophical. Thank you guys for watching, and I'll see you in the next video.